Hello everyone, welcome to Coder and Boots. So in this video we are going to cover the topic Kafka. So we'll see how you can become a hero in the world of Kafka after this topic. Okay, so it's a short video, so you will be able to understand the fundamentals of Kafka once you complete this video. Okay, so these are the topics that we are going to cover. So we'll cover the need for Kafka, like the basics, introduction to Kafka, then architecture, terminologies. Advanced topic we will not be covering in this video, so I'll post a separate video later with the advanced topics, because that needs so much of discussion. So and it has to cover several other topics as well. So I'll take the streaming and the SQL, KSQL in a different video. So let's see what is Kafka. Okay, so I've been using Kafka for more than 10 years. So Kafka is very popular in the industry, in the software industry. So there are so many queues. Okay, it's not just Kafka, but there are several other queues in the industry. So but why Kafka is very popular? Okay, so when we say queues, if you just Google in, if you just do a search for the word software queues, okay, so you will see like several queuing frameworks like RabbitMQ, ZeroMQ. So there are so many other queuing frameworks. So but Kafka is something that is meant for handling large data. Okay, it's not just for handling large data, it's basically good for medium to large size data. Okay, so compared to other queues, the main plus point of Kafka is because of its distributed nature. So other streaming or queuing frameworks, it is not that powerful as Kafka. Okay, when it comes to large size data. So when basically the big data, when people started thinking about big data, that is like somewhere 15 years back from now. So that time onwards, like queuing that much data or like handling the throughput, okay, so that became a challenge. Okay, so people were thinking about like what framework can be used for queuing this or controlling the throughput. So that's how like Kafka came into the industry. So it's open source, it's an Apache software. So and there are several other companies that offer Kafka as a service. So they have like licensed version of Kafka with them with some additional services on top of it. So but Kafka, like as a software, it is basically from Apache and it's open source. Okay, so the main difference is because of its load handling capacity and its distributed behavior. Okay, distributed nature. So Kafka, compared to other queues, Kafka is distributed. That means you can scale Kafka to any large size. Scale Kafka to any large size means depending upon your load, you can scale Kafka to any number of nodes. Let's say 100 nodes, 200 nodes. So to that size you can scale Kafka. So that means Kafka will be able to handle huge load based on that. Okay, it's not like a vertically scaling platform where it chokes after some time. It's a horizontally scalable platform. Okay, so and when to use Kafka? So when to use Kafka, this is a good question. So Kafka is something that can be used for smaller use cases as well as use cases that leads with that handles large data. Because see, Kafka can be installed in a single node. Okay, so let's say like if you wanted to run Kafka in standalone, it will lack like the replication, reliability, all those kind of things. But still, like for smaller use cases, if you are where you're not worried about like the failures and all, then you can even run Kafka in small machines, like machines with 4 GB RAM. Those kind of machines, Kafka will still run because it is just internally it is just going to run as a small Java process and it's going to run. But it can run like a Mapath as well. So basically, when in larger use cases where you wanted to handle large data, you can cluster it and to make it like a we can say like a monster. Okay, so it can handle large data as well. So and it scales like I have used in my personal projects and in my projects. I have used Kafka with like 3 lakh or like more than 1 million messages per minute kind of use cases. I have used Kafka, so and it worked very well without any performance problems. So I have right now also like several Kafka clusters in production, so that is handling huge data. Okay, So that is like, I mean, that I hope, I mean, that gives a good introduction about Kafka. And so one more topic I'll cover is basically why we need queue. Okay, so this is for people who are new to basically this kind of topic. So that's why, like, I'm just giving you like an overview of why we need queue. So let's say you have some system, so where you are getting data like with a very high throughput and maybe coming at like 1 GB per second. Okay, so from various sources you are getting, let's say you are getting data at a very high throughput like 1 GB per second. Okay, and you have some processing on the other side. Okay, so let's say your processing system is capable of handling only 500 MB, okay, per second. Okay, so let's say this is your processing capability, and let's say this 1 GB per second is something that comes during the peak hours, maybe like 9 AM to maybe 11 AM. Okay, so during this time it comes at this range. Okay, and maybe after that it goes down, then again during peak, like it goes to this kind of levels. Okay, so we need to control this throughput. I'm talking about one of the use case. So we need to control this throughput, and also let's say like if you feed this 1 GB per second input to this 500 MB per second processing system, what will happen? Because of performance issues and all, this 500 MB per second system will collapse, right? So, and also you can say like the overall system, it's not just, I mean, that's that processing system. So the overall system, we will say like it's a failure because it's not able to handle the load. So how we can make it handle the load? So we need some throughput controlling mechanism in between, right? So that is why, I mean, we have to introduce something called a queue. Okay, so queue means you have seen like queues in front of maybe like shops. So where the counter, let's say like, I mean, the person, let's say if you go to a bank, if the teller, like let's say if there is only one teller and you have so many people coming in, right? So then what is the best structure that we use there? We use queue. Like people stand one by one and first in first out. It follows like first in first out. Whoever came in first, that goes out first. Similarly, Kafka also maintains like it's a queue. In one way, if you talk, it's a queue. Similarly, another thing is, let's say in a bank, right? So the teller is there and like people started standing in queue. So the second concept we need to consider is basically the storage, right? Storage means the area, right? So let's say if the bank doesn't have space to accommodate the people, so let's say like, I mean, there is a space to accommodate 10 people, right? If you try to accommodate 30 people, what will happen? It will be a problem, right? Because they don't have space to stand. So that means queue needs enough storage to contain the people as well. Contain the people instead of people, what we can say, data, right? So it's not just a queue, it needs a queuing capability and also it needs a storage capability. So let's say like, I mean, if the teller the teller is not able to handle the customers because of the long queue, so still the queue can again, I mean, increase the length, right? So again go to further length because of the storage capability. So, and whenever like, I mean, so that means, see, people can still stand on the queue and whenever like, I mean, the teller finishes the work, they can finish it. So till the storage, it goes basically still till the limit of the storage. Let's say if the storage limit is over, then we cannot store further, or maybe like, I mean, we cannot extend the queue further, right? So that is why like, I mean, we need a framework like Kafka where it has a queue capability and it has a storage capability. So if let's say like, I mean, if consider this as Kafka, so if it is just, I mean, limited to one server, what will happen? It is again limited to the capabilities of a single server, right? So that's why like, I mean, we are extending. Kafka has the horizontal scalable capability, so where it extends the capabilities to multiple servers, right? Multiple servers. So combining these, Kafka will behave. Kafka can provide services to handle large data, large throughput, right? So this is what makes Kafka different compared to other queuing frameworks. Okay, so let's briefly discuss about the architecture of Kafka. So the architecture, so if you see like with the center part, there is something called Kafka cluster. Okay, so Kafka has something called brokers, and there is something called Zookeeper. Zookeeper, I'm not going to explain in detail about Zookeeper because I have already uploaded a video which covers Zookeeper's details in detail. So I'm just going to give heads up of what is Zookeeper. Zookeeper is a coordination framework. It's a distributed coordination framework that is used to coordinate, okay, basically services or clustered services like Kafka, okay, Hadoop, Storm, those kind of frameworks. Okay, so Zookeeper manages the metadata. It basically performs a couple of activity to maintain this group of brokers. Okay, so it is basically helper service that is used by Kafka. So this entire group management, let's say this team management, is performed by Zookeeper. Okay, so it's a coordination framework. Okay, so yeah, so I'll explain about the various roles that Zookeeper takes care of within this Kafka cluster in few minutes. So but as a high level overview, so this is how a Kafka architecture looks like. So there will be brokers. So broker is nothing, it is basically every server. Let's say if Kafka in a typical Kafka cluster, okay, so let's say there are 3 servers that we use for creating Kafka cluster. Okay, so when we install Kafka, so every server we start, so I'm not talking about Zookeeper service. Zookeeper service we need, basically that's a helper service that we need. Okay, so let's say this is Zookeeper. Okay, Zookeeper we need, it's again a clustered service. So it can run in a single node or multiple node. So multiple nodes are used in production grade installation. So let's say this is Zookeeper cluster. Okay, so now this is node 1, node 0. Okay, so node 1, node 2. Okay, so this is the 3 node Kafka cluster, assume. So and 3 node means, just assume this is like 3 servers which has some Linux OS installed. Okay, so on this, when we are installing Kafka, so one of the mandatory service, okay, so the main service that we start in this server is basically the Kafka broker. Okay, so broker, so we'll say broker 0. Okay, so it's basically the Kafka server service itself. So broker 1, broker 2. Okay, so this has 3 brokers. Basically this is the Kafka server service that runs on every node of a Kafka cluster. Okay, so that is what we call it as broker. Okay, so this is basically the worker or the guy who takes care of the activities that is going to happen in this particular node. Okay, so this every broker is kind of performs similar job. So it takes care of the storage, the queuing, okay, the topics is a couple of topics, and it takes care of the storage, it takes care of the queues, everything in that node. Okay, so and there are some coordination activities required, that is all taken care by the Zookeeper cluster. So okay, so combining this Kafka brokers and Zookeeper cluster, that gives us what we known as the Kafka cluster. So this is what we can call. And there is something called producer. Okay, so as the name explains, producer is something that sends messages to Kafka. Okay, so anyone, or it can be a client program. Okay, it's not part of the cluster or anything, so it is just a client program. Okay, it can be a Java program, it can be a Python program, or it can be maybe we can even have some other client connections, okay, that can send messages to Kafka. Okay, so that is the producer. And consumer, as the name explains, so it is basically someone who pulls or reads messages from Kafka. Okay, so if you have this entire thing in one place, that is what we say we can call it as the complete picture, right? So in simple terms, we have producers sending messages to Kafka and consumers reading from Kafka. Okay, that is the high level summary. Okay, so and here when producer sends the message to broker, okay, so what it will do is it will basically use Zookeeper for one of the activity. So what is the purpose? Zookeeper, it will use Zookeeper to identify the brokers. Okay, so basically Zookeeper keeps a track of all the metadata, right? So it knows what are the active brokers in the system. Okay, and it knows who is the leader of a particular topic, right? So all those kind of thing it has. Okay, I'll explain gradually once we progress with the session. So but it knows the entire information of the Kafka cluster. So that is why producer always connects with Zookeeper to understand some of this metadata. Similarly, even consumer. Okay, so when a consumer consumes messages from Kafka, so it updates, okay, so the track of what was it read, how much it read from the queue. So when we say consume from a queue, right? So queue also it is like first in first out, right? First in first out means whatever we have consumed, we need to keep a track of that. Okay, so Kafka is not directly keeping a track, or broker is not directly keeping a track of that particular offset, but it's basically the consumer and the Zookeeper. So they do a communication and takes care of how much messages was consumed by a particular consumer. Okay, I'll explain this further. Okay, so in once we progress. Okay, so this is basically the high level architecture of Kafka. Then I will give you a real life example. Okay, a fleet management company. So this is like a good example where we can use Kafka. So you have seen like Uber. Uber is basically a taxi service, but let's say think about like, yeah, we can even think about a fleet management company where it has so many vehicles. Okay, so and they wanted to track from the corporate office, they wanted to track the speed, okay, fuel level, driving style, okay, engine location, engine parameters, location of the vehicle, so and XYZ parameters. Okay, all these they wanted to track from all the vehicles. Think about the fleet management company has almost 1 lakh vehicles. Okay, so that means every minute they wanted to keep a track of all these vehicles from their central location. So in this case there will be some sensor attached to the vehicle that will be tapping. So usually it will be from the OBD port, right? So if you are familiar with, like, I mean, the OBD port in car, so once you connect the scanner to that particular port, you will be able to see all these metrics from the car. So the speed, fuel level, fuel consumption, right, driving style, location, engine parameters, all this info we can get from that OBD port. Let's say there is a sensor attached to the particular machine, the car, and we have some agent program running over there that sends that sends the data to our central Kafka, okay, central platform. So that means we will be receiving, let's say 1 lakh vehicles means 1 lakh events will be coming. Minimum 1 lakh events will be coming every minute if the acquisition frequency is limited to 1 minute. Okay, so think about this, right? There are so many vehicles, like cars they have, trucks they have, vans they have, and all these vehicles are sending data to Kafka. Okay, so that means we have a good use case, right? So we need a Kafka cluster. So that means because why we need a Kafka cluster? Because let's say if there is a broker failure, right? So if one node goes down, let's say if one node goes down, if there is something called replication in Kafka, so that means we can replicate the message channels, okay, across multiple nodes. So and these nodes means these brokers can be located in the same data center or in the multiple data center. So within the same data center itself, as a replication strategy, we keep it in multiple racks, so that if a rack fails, there will be another active broker in a different rack. If a data center fails, there will be an active broker in a different data center itself. That is how we replicate it. Okay, so this will be sent to this Kafka. So this means the Kafka means Kafka cluster, and then From the Kafka, again, we will use it for maybe like, some transformations and calculations. So it is just, a high level flow. So in a real production scenario, the clients won't be directly connecting to Kafka. There can be some layer in between, like, maybe the sensors might be sending the messages in MQTT or maybe in some REST APIs. And from all those MQTTs, those messages are collected and pushed to Kafka. So then transformations, maybe there can be another layer of like Kafka topics in between for further processing, and then storage, insight generation, etc. So but here I am just explaining a high level flow, so just to make you understand about the fundamentals. Okay, so here I am just giving all these vehicles sending messages to Kafka, then after the transformations and calculations getting stored into a database. So this can be like a time series database or maybe a relational database. So then depending upon the use case people can design that. Then from there, maybe there will be some derived tables where they can see the insights, and then some external application or some visualizing framework can visualize it. Okay, so this is a typical use case of Kafka. Okay, so I'll give a real life example. Okay, so a practical real life example in a different video, but this one I'm just giving a high level overview. So then let's discuss about the broker. Okay, so we'll get into the terminologies part. So broker, as I explained, it's basically the server that takes care of like the storage and management of the events or messages. Okay, so what's the message? Message is basically one event that is sent by a particular producer. Okay, so that is what we call message or event. Okay, I'll show you a sample event as well. So broker is basically nothing, it is the server or the service that runs on a node, okay, that takes care of the messages and storage. Okay, so depending upon the number of nodes in the Kafka cluster, so depending upon the number of active cluster nodes in the Kafka cluster, the broker also will be in that same number. Let's say we have a cluster with 30 nodes. Okay, so that means we have 30 Kafka brokers. Okay, and every broker will have a unique ID, and that unique ID and related metadata will be managed in Zookeeper. So now we will explain about the various roles that a Zookeeper takes care in a Kafka cluster. Okay, so Zookeeper, so if you see, it's playing a very crucial role in Kafka. Okay, it is not just in Kafka, it's basically doing similar crucial roles in several other distributed frameworks. Okay, so if you see, it's basically doing coordination and synchronization services, I explained. Okay, so some of the crucial services are basically keep tracks of which brokers are part of the Kafka cluster. That means whenever a broker joins a Kafka cluster, okay, whenever we add, so the beauty of Kafka is we can add or remove brokers to the Kafka, okay, without creating any downtime. Okay, there is a decommissioning process and there is a commissioning process. Okay, so when it gets joined, so in the broker configuration, one of the critical configuration that we need to add is the Zookeeper details. Okay, so basically Zookeeper broker knows which Zookeeper to connect. Then Zookeeper tells, okay, so you join this cluster. Okay, we have several other nodes, and Zookeeper performs the introduction to the remaining team. Okay, so whenever somebody is going to leave, so then also it is going to get registered through Zookeeper. Okay, so that means it takes care of tracking all the brokers which are part of the cluster. Okay, so then second thing is, it within the brokers also there is something called leaders. Okay, so there are some other topics called topics, partitions, okay, partition leaders, etc. Okay, so this is all managed by basically the Kafka brokers leader information, partition information. So it's basically the entire metadata of Kafka is stored in Zookeeper. Okay, so I'm not explaining the broker, the partition and the topic right now. I'll explain in few minutes. Okay, so that is why I'm not going to get into detail here. Then next is basically whatever we are storing, the metadata. As I explained, metadata means it has configurations, topics, permissions, everything, right? All these, the basically when we create a topic, we say how much replication we need, then how many partitions we need, what's the partition key, all these we specify. Okay, so that all information, okay, all those information are stored in Kafka. Then okay, so this is basically sends notification. This I already explained. So when a topic gets created, or a broker dies, or a new broker comes up, okay, so deletion of topic, all these kind of message passing, metadata management, everything is taken care by the Zookeeper. Now let's discuss about a producer. So producer is someone who sends or publishes or writes event to a Kafka cluster. Okay, so you have to remember all these topics. The reason is, so once you have an idea of all these topics, then it is very easy for you to get into the hands-on practice. Okay, so Kafka is very easy to learn because the complexity is all within the framework. You don't have to worry about the complexities within that. It is given in a very simple way, very easy to install. Anyone can install a Kafka for practice in just 5 minutes. If you have a computer, you can install Kafka within 5 minutes, and you can write a program to send to Kafka in maybe another 5 minutes. Okay, consumer in another 5 minutes. So that means in less than 30 minutes, you can try out or you can complete your hands-on practice on a Kafka, including the installation. That's the simplicity that Kafka provides. So coming back to the topic, producer is a client application that publishes events to the Kafka cluster. It's like, I'm talking to you, right? I'm producing my messages, right? And it is going through YouTube. YouTube is the channel, and you are the listeners who consumes the data. So this is the same way. Okay, I keep publishing so many topics. It is going through YouTube. So YouTube is basically storing it. Okay, it is queuing it, and it is giving you the stream feature as well, right? Similarly, Kafka also gives all these features. Okay, so now consumer, in simple words, consumer is a client application that subscribes to the events. It's basically someone who is reading the messages from the Kafka is called consumer. Okay, event. Okay, so event is a message. As I explained, event is a message that is sent by the producer. So a sample event. Okay, so this is based on the example that I have given some time back, the fleet management company. So I just prepared a JSON based on that use case. So I prepared a simple JSON. Okay, if you see, we have vehicle ID. Vehicle ID is some ID that uniquely identifies the vehicle. Okay, so that's why I put C for car, and maybe we can use T for truck. Okay, V for van. So C_200 is the vehicle ID. Then type of the vehicle. So it's car. Then timestamp. So we need timestamp at which the data was collected, right? Then data points, right? So this is the basic metadata of this particular message, and then the data points. So engine temperature, okay, so then speed, right? Fuel efficiency, location, latitude and longitude, right? So basically this gives so this is a simple one. So maybe we can even include the engine parameters and the different other parameters associated with the vehicle at any point of time. So but if you see this message, so this message covers the state of the vehicle at that point of time, right? So if you send this message to the Kafka, or basically let's say the client application, the producer sends this message to the Kafka, so the consumer can read this message from the other end, right? So let's say you have several thousands of producers sending this similar messages from all these vehicles. So Kafka will take care of handling this, and at the other side the consumers can read this and do, maybe let's say if they wanted to track vehicle 1, right? So every 1 minute, okay, so this C200 sends messages. So every 1 minute the consumer will be receiving this message, and it can do a plot of where this vehicle is traveling, right? Where it is going, and it can keep a track of the movement. Okay, so if you want to reduce the acquisition frequency, that let's say you can send it in maybe 5 seconds or 10 seconds, or maybe even you can send it in 1 second as well, right? It's up to you to decide what's the acquisition frequency that you need to do. Okay, so but just to remember, so this is not Kafka, it's a queue, right? So it's always goes in first out kind of thing. There are techniques to basically get the messages, whatever you send from the producer side to reach the consumer side in fraction of second kind of thing. But still, it's not going to be like a WebSocket communication where you will be getting immediate pop-up, right? Because it always goes in queues, right? It's a queue. So first in first out kind of order it maintains. So it will always, so if there are so many messages to process, then it follows the process. Okay. So then now let's get into the concept called topics. Okay. So topic is something that is the channel that is for sending the message, right? So we have discussed about like the messages, we have discussed about producer, consumer, right? Now we need the messages to be sent in categories, right? Let's say I have a huge Kafka cluster. Okay, so if you simply send messages to the Kafka cluster, right? So think about like not having a category or no way to organize the message. What will happen? So the consumer also don't know what to consume, right? He is expecting maybe the fleet management related data, but there are some other use cases also sending data to this Kafka. So if there is no way to organize the message, it will be a mess, right? We'll end up having so many messages in the queue. We don't know what is in the first order, right? So we don't know what's the order, everything, right? So we need to organize the messages in a proper way. So in laptop or computer, what we use folders, right? Or directories. So in Kafka we have something called topic. So it's like the channel where the messages are organized. So let's say in this case, if we have a topic with the name fleet management, right? So the producers will send the messages to fleet management topic, and the consumers will subscribe to the fleet management topic. So it's basically the channel that we use or the Kafka use for sending and receiving the data. So a Kafka can have any number of topics. So theoretically it can have any number of topics. It's basically like it depends on the number or the size of the Kafka cluster. Okay, so you can have any number of topics created in the Kafka. So that means you can have topic 1. Okay, so and similarly you can have topic 2, topic 3, and producers, maybe this guy is sending, this is related to use case 1, right? So we create a use case, topic for use case 1, and all use case 1 related data goes to topic 1, all use case 2 related data goes to topic 2, and similarly the consumers consume from the 11 topics. Okay, and another beauty of this Kafka is basically multiple producers can send to the same topic. Similarly, multiple consumers can read from the same topic. That means it is not just limited to one person, it's like so many. Okay, so you can decide. So there are some there are some differences in this approach. It's not about sending data, but at the recipient side, so there is some common common fundamentals you need to understand before configuring multiple consumers. So I'll explain that soon. Okay, so now, so as I explained, multiple producers can write to the same topic, multiple consumers can read from the same topic. Okay, and again one more thing, so this messages follows the order. So whoever entered first leaves the Kafka or gets consumed first. Okay, so there is one more subdivision within the topic that I'll explain soon. So that is called partition. Okay, so partition is something that is again subdivided. It's basically within a topic itself there is something called partition. Okay, so a topic, so when we say a topic, right, so Kafka is distributed. A topic can be distributed across nodes. Okay, so a partition is something, basically it's a part. Okay, it's a subpart of the topic, and the events that you are sending, okay, it gets basically saved into one of these partitions. Okay, so and consumer also, when it reads, it gets consumed from the partition. So the beauty here is, let's say we can arrange the messages in this partition based on a key. So let's think about like the scenario where, or the fleet management use case. Okay, in the fleet management use case, so we had multiple trucks and cars, right? So let's say I wanted to create a partition based on let's say car. Okay, so I wanted to car to come in one partition. So let's say this is the topic and this is partition 0, partition 1. Okay, so this is the topic. Okay, and this is 0, and this is 1. Okay, so when the producer sends message, okay, so what's the rule to for a message to get into partition 0 or 1? It's basically based on something called partition key. So we can say what is the key that decides or defines a partition. Okay, so let's say we have something called the vehicle type, right? So we can use vehicle type as the partition key. Type. Okay, so this is the partition key. So vehicle type, car will go to partition 0. Okay, so this car will go here and truck will go to the, okay, so vehicle type of car will go to the 0th partition and vehicle type truck will go to the first partition. So that means all, and another thing is, so basically the partitions within a partition is where the sorting happens. Okay, so that means the messages in the partition, it is basically sorted properly, first in first out, and also there will be numbers associated with every message. That number is called offset. Okay, so basically every message has like a order, or it follows an order and has an offset as well. So the consumers read from this partition. Okay, so let's say you wanted a consumer that reads from partition 0. Okay, and let's say you want a consumer that reads from partition 1, right? So let's say you can have two consumers, okay, or two consumers, so that can read from partition 1 and partition 0, right? So you can create like a consumer group here. So that basically takes care of reading from these two different partitions. Okay, so this consumer and the consumer group we will discuss in few minutes, but think about, like, I mean, topic can be further divided into multiple partitions. It's a topic level configuration, and it's the partitioning logic is based on the key. If you are not specifying a partitioning key, what will happen? Kafka will do this partitioning internally. Okay, so it will apply a hashing logic on the message and then it will do the partitioning internally. But if you are specifying the partitioning key, then the partitioning will happen based on the logic that you put. Okay, so this is like, I mean, in production use cases we specify the partition so that so you will be able to read the car related messages easily, you will be able to read the truck related messages easily without having a mix of car and truck. Okay, so this will be very easy, or this is kind of a configuration that we do while creating a topic. Okay, so if you say, like, I mean, what's the channel here? Topic is the channel. Okay, so consumer will be sending the message to the topic. Internally it will be routing to the partition based on the partition key. Okay, it can route here or here. Okay, based on the partition key it routes here or here. Okay, similarly consumer reads from the topic and it gets read from the partition based on the configuration that we specify in the consumer. Basically, like, let's say if we have a consumer, see, if there is only a single consumer, what will happen? There is no choice, right? The single consumer will read from both these partitions, right? But if there are more than, I mean, if we have multiple partitions and multiple consumers, then it applies a logic for reading the messages from the partition. I'll explain you that in detail, but just understand topic has some internal subdivision called partition, and partitioning works based on a key. Okay, so now let's explain about consumer group. Okay, so let's discuss about consumer group. So consumer group is basically a group of consumer that consumes data from Kafka topic. Okay, so in scenarios where, let's say, we have millions of messages coming to the Kafka topic. Okay, so what we do, we basically, in order to scale the processing, so we have to read that messages in parallel, right? Read that messages in parallel means, let's say I am getting 1000 or 1 million messages, or maybe 10,000 messages in one go. Okay, so 10,000 messages per second. So, and I have partitioned the topic into 4. That means, and based on the partition key, somewhere around 2500 messages will go to partition 0, 2500, next 2500 will go to partition 1, and the remaining 2 also will follow the same thing. That means approximately 2500 kind of messages will come in each partition. Okay, how can we scale this? So we create something called consumer group. So what we'll do here, so we will group a set of consumer, and that consumers will internally cooperate and read the data in parallel. How it will read the data in parallel in the scenario? So we define something called a consumer group with 2 consumers. Okay, so this is consumer 1, C1, okay, and this is C2. Okay, C1 and C2, and this is consumer group CG1. This is the consumer group. Okay, so this C1 and C2 are the consumers which are part of consumer group 1. Okay, as it is part of the same consumer group, so this consumer, both the consumers will not read the same data. So what will happen? Consumer C1 will read from car, and C2 will read from the next partition, because here if you see, there are the number of partitions and the number of consumers within the consumer group are the same, right? So because of that, what will happen? C1 will read from one partition, C2 will read from another partition. Okay, so let's say, so that means C1 and C2 will not read the same message. Okay, so whatever C1 consumes, it will be unique. Whatever C2 consumes, it will be unique. It won't mix. Let's say you wanted the same messages that is consumed by C1 and C2 for some other use case. So what you will have to do? You will have to basically create another. You will have to read it from another consumer group. Simply you can define a consumer group CG2. Okay, CG2 you define. Okay, just define a consumer group consumer group 2. Okay, so inside this you can have again consumers. You can have one or more. Okay, so the max number of ideal consumer is basically limited to the max number of partitions. Okay, within a consumer group. Let's say I have a consumer group which has 3. What will happen? My topic has only 2 partitions. So third consumer will be ideal in that consumer group 2. So let's say this is C-1. Okay, and I have another consumer, that is C-2. So what will happen? This is a separate group, right? So this group follows again a different order. So this will read from the same partitions, right? So here across consumer groups, messages, the same messages will be repeated, but within a consumer group, C1 will not read the messages that is read by C2. Similarly, C2 will not read the messages that is read by C1. Okay, so in the consumer configuration, so when we say consumer, it's a client application for reading data from Kafka topic. So in that we have some critical things to configure or specify, right? One is topic, right? Then second is consumer group, right? So this consumer group and topic we need to specify. Then depending upon this, like basically internally it will align. Okay, so in case of CG1, the consumer group will be CG1, right? In case of CG2, the consumer group name will be CG2. Okay, C1 and C2 will not read the same message. C1 will read from partition 1, partition 0, C2 will read from partition 2. Similarly, C1 dash and C2 dash won't read the same message. It will read from individual partitions. But C1 and C1 dash will read the same message because it is across different consumer groups. I hope this is clear. Okay, so this explains the high level information about what is a consumer group. Okay, so now let's discuss more about various scenarios. Okay, so this I have already given a high level overview, but let's discuss in detail. So this as in this scenario we have a topic with two partitions, and we have a consumer group with one consumer group. What consumer? Okay, in this scenario what will happen, as the arrow shows, the single consumer will read the messages from both partitions. Okay, because there is only one consumer, so it has to read everything, right? That's why it reads from partition 0, partition 1. Okay, so here the performance, like consumer 1 has to read everything, it will take its own sweet time. In second scenario, okay, so in this second scenario we have two partitions. Okay, two partitions, single topic, and two consumers within a single consumer group. Okay, as this belongs to the same consumer group, as I explained, consumer 1 will read from partition 0, consumer 2 will read from partition 1. Okay, and because it will not read the duplicate message, it will read. Okay, it will update the offset, it will read, update the offset. Okay, so it will read different messages. Third scenario, so we have two partitions and three consumers within a same consumer group. Okay, so here the third consumer will be doing what? Nothing, because the number of partitions here are less than the number of consumer within the consumer group. Okay, so the rule is, within a consumer group, the number of consumers should be less than or equal to the number of partitions, okay, within that topic. Okay, so that means, I will repeat again, within a consumer group, the number of consumers should be less than or equal to, the max number of consumers should be less than or equal to the number of partitions present within a topic, within the topic that is trying to read. Okay, in this scenario we have three consumers, but we have only two partitions. That's why only this guy and this guy is reading, but the third guy is sitting idle. Okay, so in this scenario, this is the fourth scenario, where we have two consumer groups. Okay, this I have already explained, two consumer groups, and in each consumer, so two consumer group means consumer group 1, consumer group 2. So consumer group 1 has one consumer, consumer group 2 has one consumer. Okay, so in this scenario both the consumers will read the complete message. So we need this kind of scenarios in certain use cases. Let's say we wanted to process messages in one form in one place and in a different form in a different application. So in that scenario we need to read so basically both the consumer need the same messages. That is where in those scenarios we will apply this technique. We will configure different consumer groups for those consumers. So this is the fifth scenario. Okay, fifth scenario, where we have four partitions, okay, and two consumers. Okay, so what will happen? So this is a scenario in the other way. So the number of consumers are less and the number of partitions are more. This is also possible scenario. So what will happen? So some partitions will go to first consumer, so some partitions will go to second consumer. Okay, so that means the messages will be distributed across this consumer, and the consumers process that message in parallel. Okay, so in this scenario the max consumer possible is up to 4, because we have 4 partitions, right? And so that's the rule. So now let's discuss about a practical use case, like a taxi booking use case. So taxi booking use case, you might have seen like applications like Uber, where you make a booking, right? So what you do, you basically put the location details, everything, okay, make the payment, right? Payment is not going to go while you do booking, but there will be payment validation that will be performed before that, right? So when you do a booking, so what it will be going is, it will be basically doing a booking request from your mobile app, right? So I'm just giving a high level architecture, that's why the intermediate components are missing. But if you see here, the booking request goes from your mobile app and it goes to the central system, Kafka, and let's say like it has two partitions. Okay, so partition 0, partition 1, right? And let's say the messages like gets distributed based on maybe like the type of car or something. Okay, so but what I am configuring here is I am configuring two consumer group, one for driver allocation and second for notification. Okay, basically immediately after you make the request, okay, I want a notification. So this is like a cooked up story. So you may ask like why can't we send the notification from the same service? Okay, so basically like but you think so the use case in from a technical point of view to just explain the internals. Okay, so let's say, so the second consumer groups also get the same message, first consumer group also gets the same message. So the first message here, what it will do, this service will take care of allocating the right taxi driver. So maybe like it is going to find or search across the available drivers, okay, nearby, then to the next nearest location. So all those kind of things this service will take care. And the second service, it will immediately send like, okay, we have accepted your booking, so we are finding the driver for you. Okay, so that is what the second service will take care. Booking acceptance, and here, so once this guy finds a driver, it sends the booking confirmation back. Okay, so this is like booking acceptance, and here it identifies the driver and then it sends the confirmation back. So that means in this scenario we need the same message to be consumed by two different services that runs in a different way. Okay, so in this scenario we need what? Notification consumer group separate and driver allocation consumer group separate, and both the consumers or the services get the same message. Okay, so I hope this example is clear. Now this is an important topic in the Kafka world, okay, that is called offset. So offset is important because let's say while reading the message, okay, so let's say if the consumer goes down, what will happen? Let's say like you are counting apples, you have like a heap of apples and you started counting, okay, 1 2 3, and you started keeping the apple on the other side, right, whatever you counted. Let's say you have like 3,000 apples to count, so you just remember in your mind you are just counting 1 2 3 like this. If you count, in between you got a call, okay, so you stopped the counting and then went to attend the call, came back, then you forgot what was the last number that you counted, right? So if you forget, in that case the same thing can happen here as well if you don't maintain the offset. So let's say you are keeping a track of that offset in a paper. Okay, so let's say in this scenario, let me explain back. So think about a scenario, the same thing, heap of apples, so many apples. Okay, so this is like the way I draw apple in this example. Okay, and you are counting, okay, and keeping it in another place. Okay, so whatever you counted, you keep it in the other place, and there also you just create a small heap. Okay, so in between someone called, so you are counting in between. You are standing, okay, standing and counting. So in between a call came, you forgot what was the last number. So but if you keep a pen and paper with you, and let's say if you keep a track of the count in this paper, what will happen? Even if you receive phone call multiple times, let's say if you go for food also, you can still continue the count without losing the track of how much you counted or how much apples you counted, right? So the same thing is applicable in Kafka as well. So this in Kafka, this count is maintained at basically this offset is maintained at a level of partition, okay, because that is where, so as I explained, so when a topic is created, okay, so by default if you're not specifying the partition, what will happen? It will be coming with one partition, right? So but let's say like if you are partitioning it, so what will happen? If you are specifying the key, then the message gets partitioned based on the key, okay, and it gets stored in multiple partition. and when a consumer is reading the message, from consumer reads from a topic, and internally it basically takes the message from the partition, right? So, and I explained about 5 scenarios where how the messages are read by the consumers within the consumer group. It can read sequentially, that means within a partition, within a consumer group, consumers read messages from partitions, right? And it won't read duplicate messages, right? So this offsets are maintained at a consumer group and partition level. Okay, so basically, like, I mean, this need to be maintained at consumer group plus partition combination, right? Because for a different consumer group, the offset might be different. Because, for example, in our taxi use case, okay, so in this booking use case, this guy might have read 20 messages. Okay, so that means here the partition, here for the notification consumer group, notification service, one service from partition 0 maybe read 30 messages, partition 1 40 messages. Okay, so here driver allocation service 1 might have read 60 messages, and driver allocation service 2 might have read 20 messages, right? So depending upon the consumers within the consumer group and the partition, the offset varies. Okay, so that means, so here if you see driver allocation group for a specific partition, so we say, okay, this offset is 1, offset is 3. So this 1 2 3 is just, I mean, basically the number. Okay, so it can be like, I mean, in thousands, okay, depending upon the number of messages. So this metadata is also internally stored in, like, I mean, it's basically kept in Zookeeper, and it's basically available in a topic as well. Okay, so this is like, I mean, again, that's why, like, if you see in the initial architecture, I have explained consumer will be writing the offset information to Zookeeper, right? So this message is internally tracked in Zookeeper. Okay, so that is the offset. So with the help of offset, so if you keep a track of this offset, what you will gain, if you keep a track of the offset, then let's say if your consumer dies in between, okay, you can still you still know what is the last message that you read. You can read from the remaining offset. Okay, so you can use that offset to start reading again. Similarly, like in between, Kafka server went down. Okay, so but still Kafka has a persistence layer, right? That means the messages are not gone, right? So if your Kafka server goes down, I mean, if the server stops, the messages are persisted locally. Okay, so, and also there can be other servers also running, right? It's a clustered service. So that's why, like, I mean, you will be able to still establish the connection and read the remaining messages by using the offset. So offset is an important topic. I will show you the usage of this offset in an upcoming video by using a practical example. Okay, so I think, I mean, with offset, one more topic I forgot to explain is basically the replication. So replication is how, like, I mean, so I have not added a slide for that, but I have already covered it some time back. But so topic, basically we can configure replication for a topic. So we can, I mean, minimum number is 1, so max can be any number. Okay, so basically that many times the topic's data will be replicated across brokers within a Kafka cluster. So people usually use 3 for production use cases because it can handle rack failure. It can handle, because if a rack fails, there will be a second replica available in a different rack, and if the data center fails, there is a third replica available in a different data center. That is how, like, I mean, people maintains the replication configuration. Okay, so but technically we can configure any number as a replica. Okay, so with this, I think, I mean, high level of like the Kafka, the technology Kafka, I have explained, okay, in a theoretical way. So I'll show you the practical session. Okay, I'll cover a practical session in an upcoming video, so stay tuned for that video. If you have any questions related to this, like, feel free to comment below this video. I'll definitely respond back. Thank you for watching this video.